Welcome back. So the next topic is solving linear simultaneous equations. So let's have a look at what this means. So simultaneous just simply means two equations side by side. So in this case we've got one equation x plus y is 10, the other equation x minus y is 8. And linear, what we mean by that is we mean that the highest power of x or y is just x to the power of 1 or y to the power of 1. In other words, there's no squared in it or cubed or anything like that. So how do we solve this kind of thing? Well, one thing to mention is if we just had one equation here, so if we had this top one, x plus y is 10, we can't solve that one because we have what's called two unknowns being x and y, and just one equation. So there's no way we can solve this top one on its own, or in fact the second one on its own. But if we're able to combine equations 1 and 2 in a certain way, such that we can now form a new equation only in terms of x or only in terms of y, then we can definitely solve it. So what we're going to do here is we're going to add equations 1 and 2 together. And how does that work? Well, on the right hand side now it's just going to be 10 plus 8, and on the left hand side it's going to be x plus y plus x minus y. And then if we simplify this, we're going to have x and x, which is 2x, and then we notice the y and the minus y, they're going to cancel, and then we have 10 plus 8, which is 18, and that means when we divide by 2 that x is going to equal 9. Now there's something else to mention here. Because it's simultaneous equations, we're always going to have two answers. So in this case we're going to not only have an x value as our answer, but we're also going to have a y value. So just make sure to remember that. So how can we get this y value? Well, what we could do is we can take this value of x and we could substitute it back into either equation 1 or equation 2. It doesn't really matter which one. So let's maybe do it, sub it into equation 2. So when we do that, we're going to get x is 9 now. We're going to get 9 minus y is 18. If we add the y to the other side, that will give us 9 is equal to 8 plus y. And then when we take the 8 away from both sides, we're going to get y is equal to 1. Let's look at another question here. So again, we've got two simultaneous equations, and so we have 2x plus y is 10 and we have x plus y is 5. Now in the previous example we actually added equations 1 and 2, but in this case we're actually going to take them away. So let's do that. So we're going to do 1 minus 2 in this case, and that's going to give us on the left hand side 2x plus y minus, and be careful here because it's really minus all of x plus y, so I recommend putting a bracket around it. And then on the other side it's going to be 10 minus 5, and then if we simplify this, it's going to be 2x plus y minus x minus y is equal to 5. And then if we further simplify that, it's going to just give us x is equal to 5, because the y and the y will cancel out. And then again, remembering we need to get a y value as well. So if we put it back into this equation, then we're going to get 5 plus y is equal to 5, and that has to mean that y is equal to 0. Now let's look at these two previous examples again side by side, because how can we tell, for example, whether to add the two simultaneous equations or whether to take them away? How do we know that? So if we say, for example, we would like to cancel out the y's, and we just circle just this bit on its own, then you have to ask the question, well, how do I cancel the y's? What do I have to do to the y's to cancel them out? Do I add or subtract? Well, if I do y plus minus y, in other words a plus here in the middle, then this will give us 0, because y plus minus, that becomes a minus, and then y minus y is 0. So that's why we would want to add these two equations. So we're adding 1 and 2 together. But then in the second case, again, if we circle the y's, well, we can't add y and y together. That's not going to cancel them out. But if we did take them away, so taking away both sides, we would have y minus a positive y, which again, a minus and a positive make a minus, and then that will again give us 0. So that's really the trick to these. Look at the term you're trying to cancel. You can cancel the x or the y, depending on what's easier, and you're essentially either going to add or subtract. That's the main operation with these. You're never going to times or divide with these types of simultaneous equations. Let's look at another question here. So again, we've got two simultaneous equations, and we would either like to add or subtract them to form a new equation in terms of either x or either y. However, the problem here is if we were to look at these two equations and, for example, just circle here the 6 and the minus 3y, well, if we were to add these or subtract them, we're still going to have y terms and we're still going to have x terms, essentially because the numbers in front of x and y are different. So in previous examples, we always had the same overall numbers in front of y or x the same, but in this case, because they're different, we can't just add or subtract to start with. So what we would like is to have the numbers in front of x to be the same. We're not too worried about the signs being the same, but we really want the numbers in front of y in this case to be the same. So what we would like is we would like a minus 6 here instead of a minus 3, because there's a positive 6 here. So to achieve that, if we double both sides of this equation, so we're going to times equation 1 by 2, making sure to times all of the left hand side by 2, that's why I put a bracket there, then what are we going to get? Well, we're going to get 4x minus 6y is equal to 20, and then we can write this other equation underneath again just for ease of comparison. So then we notice now that we have a minus 6y and a positive 6y, so definitely if we add these together now, then these 6y's are going to cancel out, which is what we're trying to achieve, and then we will have 4x plus x, which is 5x, the y is disappearing, and then we have a 35 on the right hand side, and so in this case then x will just be 7, and this is a little bit more complicated in terms of subbing x back in to get y, but it's definitely still possible. So if we put, for example, 7 back into this one, then that would give us 7 plus 6y is equal to 15. If we then take 7 away from both sides, we're going to get 6y is equal to 8. And then if we divide both sides by 6, we have y is equal to 8 over 6. And you can leave it like that, or sometimes it's nice to cancel it down a little bit more. So y is equal to 4 over 3.